Hi guys, today I want to show you how we can use the Viterbi algorithm to calculate the most probable global tag sequence for out-of-speech tagging for a very small example with just 3 possible tags and a sequence of 5 tokens. And we have the emission probabilities and the transition probabilities given here because that's, of course, we need that. And what we start with is that we can, of course, start in all possible kind of states in the hidden Markov model. So we check and calculate the probabilities for each. In this case, starting with the determiner has a probability of 0.6, and then emitting the token the also has a probability of 0.6. So this is 0.36. For the next one, starting probability is 0.3, and emission probability for verb is 0 because it's not in the table here. So that's 0. And starting probability for noun is 0.1, and emission probability for noun also is not in the table, so it's 0. So this one is 0 as well. And now remember that in the hidden Markov model, the next state only depends on the current state. We can use this fact to calculate the most likely sequence of state transitions by doing the following. First, for every state that we could be in, we figure out which one is the likeliest source, including the emission probability for the current state. All other transitions ending up at the current state will certainly not be part of the globally most probable path, as we already identified one that's more likely. And after that, when we are done with doing this step for every possible state we could be in, for every emission we observed, it's easy to find the best combination of these most likely hops by walking the path backwards, always following the most probable source. And here in this next example, we can do it a bit easier because we only have one possible source state, the determiner state. So we know that for every next state, this will be the maximum because all the other options don't exist. So we can just directly calculate the transition probabilities and the general probabilities for being in these next states, already knowing that the determiner state will be the most probable source state. So that's what we will do now. For determiner to determiner, it's 0.1 for the transition. Car determiner emission probability is doesn't exist, so it's 0. So this thing is 0 coming from determiner. And in the verb state, here we have to check for the probability of verb given determiner, and that would be 0.2. And then the emission probability for car given verb 0.1. And we should write down that we come from determiner here. And then we also have to take this probability here because we want to continue the path probability. So we always have to multiply with the previous state's probability. And this will result in, now for the last state, we have the transition from determiner to noun state, which is noun given determiner, which is here. So that's 0.7 times, and then the emission probability for car given noun, which is 0.4, and the probability that we end up here, or that we continue this path, is this, and we should write down that we come from the determiner state, and we of course multiply it, and we get this. And now the stuff gets more complicated because we have multiple paths we could go, but we want to go the one that's most likely, the most likely transition. So we will just calculate the maximum of moving from the verb state into the determiner state. That is determiner given verb times, and then we emit, or we want to know what's the probability that we emit lead in the determiner state, times the probability that we went this path. So that's this one. And the other option we have is coming from the noun state, which would be determiner from noun times probability lead in determiner, which is the same. And this has another probability. But we can see that lead, emitting lead when we are in the determiner state doesn't exist here. So this is 0, and this is also 0. So this entire thing up here is 0. Next up, we check the scenarios for being in the verb state. So we could come from the verb state, that would be verb given verb, and then we want to know what's the likelihood that we emit lead in verb, and that we come from that path, and then the likelihood, the other option would be coming from the noun state, so verb given noun times probability of lead in noun times this, that we are in this path. And then when we insert the numbers for verb, we get 0.1 for lead verb, we get 0.3 for the probability that we are in this path for coming from verb is 7.2 times 3, and verb given noun is 0.6. This one's also 0.3, and the probability for this path is 0.1008. And of course, when we multiply these, we see that the bottom one is the larger one, and that's the one where we went from noun to verb. So we put in noun here, and the number that we get when we calculate this is 0.018. And then we do the same thing for the next state, which is the probabilities that we come from the verb state into the noun state, or from the noun state into the noun state, and again emit lead given noun, lead given noun, and the probability that we end up in that state. And noun given verb is 0.3, noun given noun is 0.2, lead noun is of course the same again for both, 0.3 and 0.3. And here that we come from the verb state is 7.2, and that we come from the noun state at 0.1008. And then when we calculate this, we, of course, because of the upper term, the bottom one is the higher one. When we multiply this, of course, we have to add that the bottom one is coming from noun. We end up at 6.048 times 10 to the power of minus 3. And yeah, we will continue now with the next one. For we want to know what are the options for being in the determiner state. So determiner given verb or determiner given noun times, and that's the probability for in the determiner state, and that's the probabilities for being there again in the first place. We don't have the determiner one, so that's why we can leave it out. Otherwise there would be 3 terms in this maximum function. And yeah, we can add the numbers here again. Determiner given verb 0.6, determiner given noun 0.2, the given dt is the same for both, 0.6. That's the emission probabilities. And being in the verb state before had a probability of 0.018. Noun state had this. And when we multiply that, we see that the top one is the larger one, and that results in, and we should write down that we come from the verb here then, that results in 6.48 times 10 to the power of minus 3. Now we do the same thing for the next state. We want to end up in verb. We could come from verb, so verb given verb, or we could come from noun, and then the probability that we emit the in verb or the and noun times the probabilities that we get there. And of course, this is 0 for both. So that entire thing is 0. And then actually for the next one, we see that here we would be in the noun state. So we would take the maximum of this transition, verb to noun or noun to noun, and then emitting the in the noun state. But it doesn't have, similar to this case, doesn't have any emission probability for being in the noun state. So that will also result in a 0 for us. And then for the last sequence, it's a bit more convenient because now we only have one situation where we can come from, that is the determiner state. So we check what's the likelihood of being in the determiner state, coming from the determiner state and emitting car in the determiner state times the probability that we are there, and that's it, because that's essentially this doesn't exist and this doesn't exist. And when we want to calculate this, we can check this probability is 0 again, so that I think is 0. And then also for the other two, we don't really have to write down the maximum thing anymore, because we just have the option of coming from determiner to verb and determiner to noun, and there's no maximum that we have to take from other sources where we could come from. And in that case, I will just write down the results here because you probably know how to calculate it by now. And now we compare which one of these final probabilities, because we always multiplied with the probability of where we came from. So this is the probability of the entire path. And we just compare the likelier one, and this will tell us which path we took. So in this case, the likelier one is the bottom one, obviously. I'll just write it down here again. And then what we do is we connect this with that, because that's where it came from. And we always connect it with this thing that we wrote down where we came from. So in this case, we came from determiner. And here we came from verb. Here we came from noun. Here we came from determiner. And these classes are now the ones that we can assign to the tokens. So here it's determiner, here we were noun, here it's verb, determiner, and noun. And now we are done with this part of speech tagging of that sequence. And yeah, that's it. And I hope it was okay to understand and follow it. It's a bit annoying because you have to calculate a lot of things and then just take the maximum of it. And so the most convenient thing that can happen is that some of these probabilities are 0. Thank you and bye.